Good morning, everybody. Today is Sunday, August 21st, 2022, and yesterday I had a YouTube user, KZ Painting, that posted a question that I thought was a really good question and warranted a response video. So here we go. The gentleman wanted to know how I chose the gas shocks that I chose for my car. And it's really not that hard at all. It all comes down to torque equals force times distance. It's very basic mathematics. I'm going to show you exactly how you compute this for your car. The first thing that you've got to do is get yourself a bathroom scale, and you're going to set that down right here where the deck lid comes down. Drop the deck lid down with no shocks, no torsion arms, torsion bars, whatever. You want the thing under its own weight for that deck lid to come down and basically, pinch the bathroom scale in between the car. The deck lid will then tell you how many pound-feet that deck lid is pushing down. Mine is carbon fiber, so it's only pushing down with 10 pounds of force. I can't run torsion arms on my car, the stock factory torsion arms, because they're for a deck lid that's like 80 pounds, and if I tried to run those, the thing would just go wham, backward real fast and destroy the deck lid as soon as you release the latch. So I have to run gas shocks. If you want to run gas shocks and you don't want to run off and pay $500 for Eddie Motorsports, CNC gas strut shocks, this is how you do it. So you take that measurement. In my case, it's 10 pounds. The next thing that you do is you take the measurement from the pivot point of the trunk hinge, right there, the deck lid hinge. The pivot point from there out to the back end of the car where it touches down. On mine, that measured 32 inches. So if torque equals force times distance, there we go, then we have 10 pounds times 32 inches gives us 320 inch-pounds of torque. So at the end of the day, if we want this deck lid to kind of float in air, if you will, then we're trying to create a 320 inch-pounds torque about that hinge. So we're not really sure at this point what pound force of gas struts to order, and we can't do that until we determine where the strut is going to connect to. So I'm going to go ahead and close it here. Notice again, it's just weightless, right? So I can push it down just a little bit more. So the first thing that you want to do is determine where your gas strut here is going to mount to your hinge. This is up to you. It can be here, it can be here, it can be a number of places. Whatever, works well for you is fine. The one thing that I would caution you to is make sure that if you were to draw a line from here to here, going back with that shock, that is a 90-degree angle. If you don't do that, and it's not a perfect 90 degrees right there, then the mathematics that I'm about to show you are not going to work, and all of a sudden we have to do trigonometry and some vector forces to figure out, what you need. So the easiest thing to do is just keep that at 90 degrees when the deck lid is closed, okay? So I decided I would drill a hole in mine right here, run my shock back so that I had my 90 degrees right there. And at this point, you have to figure out, okay, what length of the strut should I order? I'm using 9 inches compressed and 15 inches extended. That is probably going to be different for you and your car and your application. I would caution you to be careful. If you run off and you mounted that way up here, then maybe as the shock extended and went up, it might start hitting into the package tray. So you kind of have to make sure that you mount that strut in a location where it is ultimately able to do that and not hit anything, as well as you want it at 90 degrees here, when it's in its closed, when the deck lid is closed. So this is simple mathematics at this point. I measure the distance from here to here. It's 4.375 inches, or 4 3/8. So now I solve for it. I've got 320 inch-pounds equals force times distance. My distance is 4 3/8 inches. That means I solve for F, so that's 320 inch-pounds divided by 4.375 inches. That gives me 73 pounds of force that I am trying to put at that point right there to make this deck lid float. If you're going to be running 2 shocks, then you're obviously going to take that and divide by 2, 36 pound shocks. I bought 35s for this car, and you can see that, they're not quite as strong as they should be. Watch here. If I open it and now it tries to close itself, right? So the math told me, Ian, order 36-pound shocks. I couldn't find 36s. I ordered 35s, and exactly what the math says should happen happens. I've now ordered some 40s that I'm going to put on it. I've still got to build my spoiler for it, as well as put the lock in the car. So I'm going to need something a little bit stronger than the 35s, but luckily these things are like $20, $30 a pair, so no big deal. So anyways, that's really all there is to it. You just got to measure the weight that your deck lid is pushing down, measure the distance from the hinge pivot point to the back of the car, measure the distance from the hinge pivot point to where your shock is going to be. Make sure that with the deck lid in the closed position that it forms, you see right there, it doesn't form a 90-degree angle at all, right? But we know that the deck lid is going to be its heaviest to try and open in the down position. That's why you want to make sure that that is a 90-degree angle, and there's a little bit more mathematics behind it that we won't talk about, but at the end of the day, that's how you do it. So hopefully I'll put the 40-pound struts on this car, and it will be good to go. We'll see. Hope you guys are learning something from me and enjoying these videos. Click subscribe if you want, man. Y'all take care.